Today we're talking about systems of linear inequalities, and so your vocab term is systems of linear inequalities, and that's two or more linear inequalities whose solution is an overlap of shaded regions. So in the last lesson you talked about linear inequalities with one equation or one inequality, and you graphed it on the coordinate plane and you shaded either above or below the line, you checked that 0, 0 point, and now you're going to have two linear inequalities to graph on the coordinate plane, and your solution set is going to be where they're both shaded in instead of one. Very important concepts. You must use multiple colors for shading to help determine the overlapping region. This is so that you can see it clearly. It helps determine where exactly your solution set is, since you are dealing with two inequalities. Your solution, there are multiple coordinates that will satisfy the system, not just one intersection point. So when we talk about systems of equations, you talk about the one point that satisfies both equations. There's going to be multiple coordinates this time, or multiple points that will satisfy your system of linear inequalities. Just like last time, you're going to always test 0, 0. If that works, you're going to shade that part. If not, you're going to shade the other part for each line. So example 1. Y is greater than 5/3 x minus 1 is your first inequality, and y is less than or equal to negative 2x plus 4 is your second inequality. So graphing this first line first, you're going to start at negative 1 as your y-intercept, and you're going to go up 5, and you're going to go right 3, and because it's greater than and it doesn't have the or equals to, you have this dashed line going through it. And then you want to shade either above or below. You test that 0, 0 point to see where you should shade. So testing 0, 0, you plug it in. Y is 0, 5/3 times x is 0 minus 1. 0 is greater than negative 1 is true, so you want to shade over 0, 0. So this is all this black shading here. That gets all shaded in above this dashed line. Then I'm graphing this line, negative 2x plus 4, so my y-intercept is 4. I go down 2, right 1, down 2, right 1. And because it's less than or equal to, and it has that or equals to part, you have the solid line. And you're going to test that 0, 0 point again to see if you're going to shade this way or that way of this line. So plugging in 0, 0. 0 is less than or equal to negative 2 times 0 plus 4. 0 is less than or equal to 4, which is true, so you want to shade over that 0, 0 point again. So that is all this red shading this way, underneath this red line. Your solution is going to be the overlapped part. So your solution is going to be the part that's shaded in red and black, and that is shown with this blue shaded in. It's also shown by this blue line that travels along this red line here and then changes to your black dotted line here. So anything that's blue and shaded in and in between this part of this line and this part of this line is your solution set. Example 2. 2x minus 3y is less than 6, and x plus y is greater than or equal to negative 1. So the first thing you have to do with this equation is you have to get them in slope-intercept form in order to graph them. So with my first equation, I'm just going to subtract the 2x over, and then I'm going to divide by the negative 3y. And don't forget, when you divide by the negative 3, that negative number, your sign flips. So my equation now, my inequality now says y is greater than 2/3 x minus 2, and I'm going to start by graphing that. So my y-intercept is negative 2. My slope is 2/3, so I go up 2, right 3, up 2, right 3. And because it's greater than, I have my dashed line. Plugging in my 0, 0 point, 0x and 0 for y, I have 2 times 0 minus 3 times 0 is less than 6. And simplifying, I get 0 is less than 6, which is true, so I want to shade over 0, 0. So this is this blue shading. Everything above that line gets shaded in because that's where your 0, 0 point is, so you want to shade where that is. Rewriting the second equation, x plus y is greater than or equal to negative 1. I move the x over by subtracting it, so I have y is greater than or equal to negative x minus 1. My y-intercept is negative 1, and my slope is -1 also. So I go down 1, right 1, down 1, right 1, down 1, right 1. And because it's greater than or equal to, it's your solid line. So that's this red line right here that goes through -1 and the y-intercept, and your slope is -1. Plugging in 0, 0, 0 for x, 0 for y, I get 0 plus 0 is greater than or equal to -1. 0 is greater than or equal to -1, which is false, so don't shade over 0, 0. Yeah, 0 is greater than -1 is true, so you do want to shade over.
That's my bad on Miss DeBeale's part.
So you want to shade over 0, 0. And since you want to shade over 0, 0, you want to shade everything this way. So your solution set is going to be the overlapping part. So your overlapping part here is along this line and then this line. So it's everything up here in brown this time. This is your solution set. And you can not worry about over here. That's your solution set.